We take our ability to move around for granted, but without a functioning hamstring, it might be impossible to perform these activities. Hello, I'm Katz. The number one injury in track and field, basketball, baseball, and a whole host of other sports is in our hamstring. Up to 3 out of 10 overall injuries stem from the hamstring. Further, there's a very high rate of reoccurrence when strained. The problem is that athletes are cleared when the pain subsides, but the injury tissue may heal in a way that's different from the original tissue, resulting in altered biomechanics, weaker muscles, which may limit range of motion flexibility, or re-tear. This is an important problem for me to address because I suffered a grade 2 tear of my long head bicep femoris muscle during an ice hockey game that re-tore, and I had to sit out a championship and deal with excruciating pain twice. My project seeks to fix this critical healthcare issue. I pulled together hundreds of images, both healthy and lesioned muscles. I use convolutional neural networks, a type of deep learning algorithm, to analyze the features of each image at different levels of detail. My training accuracy is very high, and the program I wrote can categorize new images as lesioned or baseline. I created a prototype of an ultrasound for in-home use by soldering together inexpensive components, including 2 modified piezoelectric transducers and a transistor. A high-performance microcontroller was used to apply a pulse width modulation signal at 5 MHz, and then a transistor was used to remove the driving voltage from the system at the end of the pulse. That same transducer used to create the signal detects the reflected ultrasound waves and sends them back to the microcontroller to be recorded. While mathematically, 16 transducers are needed to gather enough information to perfectly reconstruct an image, with feature detection and filtering, it's possible to use much less information, likely only half the calculated amount. This will reconstruct images to a high enough fidelity to then make muscle strain classification according to my pre-trained convolutional neural network. As a first step towards this goal, my 2-channel transducer setup is currently able to reconstruct images given a sparse sample volume. This prototype is a start to keeping us safer and stronger and ready to take our shot.